Um, so, all right. So you got a couple dozen folks working for y'all. What are your like day-to-day contracts like? You don't have Do you have all of those people working on this one task? And if so, where's your capital source?
Yeah, our team is any company could do this. So I've had a couple other businesses in the past, and I exited one. So I had some success creating something and exiting after it. And I've had a lot of time to think about good ways to do stuff. But if anyone wants to start their own business, you can just go down, register at the State Corporation Commission. You can do it online.
Sure.
It's
Yep.
like $275 or whatever it is in your state or whatever. And then if you have shares, if you make a corporation, you can give people that are excited about what you're doing shares to participate. So some people are like, I don't have enough money to pay people. But what I did at Space Ocean was they're earning shares. That's kind of their income, restricted share units. And it's a model that I think Tesla did something similar. They had RSUs, equity incentive programs. So that's what we have at Space Ocean. And so we're looking at like a variety of spacecraft. We got the low Earth orbit ones. We have the one that would maybe go out to cislunar. Cislunar is going to be needing more radiation and other type of stuff on it. And then we're designing one that could be a tug for some of the smaller spacecraft. And then we're designing one with nuclear. We have a partnership with Space Nukes, and they have a nuclear reactor, which like a certain kilowatt rating, and they have other varieties that they're working on as well. So we're looking to go to like Enceladus. It's beyond the asteroid belt. So when you get past the asteroid belt, beyond Mars, the sunlight is a lot less. So you're looking at maybe 1% of the light from the sun. So solar panels can't really work. So you need nuclear or you need some other type of energy. So our partnership with Space Nukes is to develop that capability for when we actually succeed in the low Earth orbit out to cislunar area, we can immediately go out to Enceladus ASAP. But for the space industry, you can't start working on something when you're ready to work on it. You got to work on it many years ahead, because even the time to buy the components takes a lot of time. So you got to start working on it today if you want to do it 5-10 years from now. So we have several spacecraft we're working on at the same time. That's what we have, different teams working on the different craft, and some of the people work on a few of the different craft at the same time, in that specific area they're in. So.
Got it.
Okay. Can we shift gears just a little bit?
Yeah.
Because you do a lot of other things as well, and you've done a lot of analysis about the engineering things. I'd like to talk just a little bit about something you said is something that you call it engineering reality versus TRL theater. And it's basically, what does technology readiness really look like? And we're startups, and this is really important to our crew, startups paper over the hard problems and what investors should actually ask when evaluating technical claims. What do you think?
Do you have a working prototype, or have you been to space before, or do you have anything in space that you can say that's mine? And so we're working on that thing where a lot of people in our company have done stuff with other space companies, and they have stuff in space, and they've landed on the moon or whatever. We have a lot of very experienced people on the team, 20 to 40 years, experience, and they're actively in other programs as well as being at Space Ocean. But as a company, we want to get that check mark and that experience as a team where we've done something together and it's up there in space right now, and then that will help us when we're trying to get an order from another company or open a certain type of partnership, or even apply for a phase 3 SBIR or something like that, or get investment. An investor wants to see, what have you done in space? So that's what we're.
All right. Well, where do space startups paper over the hard problems, in your view? What have you seen that you mentioned that?
Some people have very small teams, and even working with people, here's a good example. We've had a bunch of military people on the team, and I don't want to say anything about those types of people. We have some are great, and some are very structured in a certain way. So depending on what you're doing, the type of people on your team it'll matter. And then who do you want to hang out with? So certain people want something done in a certain way, and I fired a whole bunch of people. We've had over 300 people cycle through. We're in the 400s now, so as a team. So
wow, we could do an entire show on that. I've had more than 50 interns at LiftPort over the last almost 25 years. Not quite 25 years. And that's complicated. I don't think I've probably had about 100 staff across all of the incarnations. That's complicated, right? That's after nearly 25 years of total time, multiple incarnations of this company. So it's hard to do that. Let's go back to that TRL theater though. Why do you call it that? By the way, I really enjoyed that language. I thought that was very accurate. So why do you call it that?
It's impressive. You can say I'm your TRL 5 or whatever, TRL 9 is the ultimate. And that's where you want to get to. You're in space, you've done stuff, it's qualified, and there's a heritage. So there's a history. So it means a lot, but even something that is qualified, we just saw SpaceX try and launch, and they've been to space a whole bunch of times, and they had to postpone it till tomorrow, maybe. So,
hopefully tomorrow. Yeah. Cool. Veronica asked if you've done any development or analysis here on the Earth, Arctic or Antarctic. I actually don't think those are the easy ones. I think it's actually if you go to Mount Washington out in Vermont, Northeast, somewhere in the Northeast. I think it's Vermont, Connecticut, maybe. Have you done any testing of your systems, live in super harsh environments, super cold environments?
Not yet. We want to. It costs about $50,000 to go to Antarctica, so there's a cost. There's a cost. We were looking at Alaska like a month ago. So, but we're looking at our options, and when it's the right time to take the equipment out that way, we will for sure.
Yeah. The reason I always talk about Mount Washington, and so far as I know, no space company has gone to Mount Washington, but it's got some of the coldest temperatures in the world, and it's a hell of a lot easier to get to than the Arctic. So it's a hell of a lot easier than the Andes or the Himalayas. So it's pretty rough up there in the New England area. So and it's a lot less expensive. We are going to do our testing at Mount Washington. So I'm just going to give you that as a freebie if you need it.
I appreciate it. I'll look into that for sure.
Yeah.
Well, one of the things that really excited me was reading your material is that you mentioned the word containerization, and that is a big topic for us. We just love it. And we kind of broke that on our show about a year ago. But the thing is, you talk about apparently you have your own ideas, and I love to hear them. Give us a kind of a systems level walkthrough of orbital logistics. How does fluid transfer really work in microgravity? What will the short-term economics be of say satellite servicing, and what that orbital depot network could look like, say, in 15 years?
Cool. Containerization is the idea that in shipping, when they had the standardized sizing and everything else, then they could the different ports could easily offload and onload the different stuff, and the ships could have a spot for their stuff. So in space, we're looking at different ways to standardize even the connectors. Rafty, OrbitFab has the Rafty, and Duralock has a different type of connector. So different. When you, if you're in Europe, you have a certain type of plug for your electronics. You plug the thing into the wall. When you come to these, it's different. So you got to get a adapter. So in space, the different space satellites and spacecraft, they don't have a standardized way yet it's a new industry. The SpaceWorks and the AFRL, all these different funders for the spacecraft haven't decided to have a certain standardized way for these things to connect in space. So it's a vacuum out there, or very close to it. So some of the space stations have like a back porch you can drop stuff off on. If you have like a you can just use an arm, and you can deliver something. It can grab your spacecraft, and then it can offload that way. But for a larger volume of fluid and stuff like that, it'd be good to have some type of connector. But that has to be put on these spacecraft before they get launched, and it takes at least a year probably to integrate that. So we're looking to be part of that and help that shape that decision. Of course, Orbit Fab has gone quite a ways, but and there's a possibility they could change the volume or the size of their connector. So that's a possibility. But there are different fluids. Hydrazine, you don't want hydrazine connector being interchanged with a water connector. So you can't use the same connector for everything. There's a large need for water in space from the military as well as the commercial sector. If people want to go up for a vacation for 2 weeks on a VAST or Starlab space, or one of the other orbital reef, or one of the different space stations or tourist places, they're going to probably want some water. If for the price of water, it's if you were on the moon, water would be so expensive that could you even have a bathtub on the moon? How expensive would that be? So we're looking to enable that and work with all the different space companies as much as we can, even internationally, to be part of that and make it more real for everybody.
Okay. Just one more thing. I know because we've all talked about Elon tonight. One of his goals with Starship Block 3 this year is to actually do a demo of on-orbit refueling. What challenges do you think he faces?
Well, today they revealed the two new spots on the Starship where that they can interface and connect the two different starships. So that was pretty cool.
Yeah.
They want to have like 1,000 starships up there, just to refuel one of them to go to Mars. I don't know if that's still current, but they were looking at, and maybe as they increase the size of the Starship, then they need less of them to do the one trip to Mars. And maybe as we get nuclear propulsion, we wouldn't need to, but there's going to maybe need a lot of, when you have a large ship go out of a port, there's a lot of like a tugboat, and there's different things that interface with that big ship. Probably going to need something like that with SpaceX and all the other space partners for that Starship to leave. Maybe we can help out with some of that fluid logistics.
Okay, but are there any red flags in terms of just doing the fuel transfer? You're doing this in microgravity. What's the challenge?
Well, when we look at the Starship, there's a lot of vapor or other stuff, a constant trickle leaving. So when this cryogenic fluid heats up, it vaporizes, or they may need to recondense it or something. So up there in space, around the Earth, and as you get further away from Earth, it becomes a bigger problem. But at least around the Earth, it'll boil off. So they got to keep sending up more fluid.
Okay.